Hello everybody. This video is with intentions to show you the frequency range and this particular design of the Guanella Balun that it's been in several books, the ARRL articles. How can we analyze it just besides the frequency, the analyzer? We're gonna be using an oscilloscope. We're gonna put a signal generator from the frequency that we tend to use it. In this case, we're gonna be using for the best practice of the specs on this particular ferrite cord for the dipole antenna. We have a 75 input signal coming to a 75 ohm part into the antenna, negative and positive. In this case, we have a signal generator based on 28 megahertz, which is 10 meters. We're gonna see here one side of the antenna versus the other side. They're 90 degrees phase in between both of them. We're gonna see this by putting them together and see what's the difference between them. And we are seeing that it's no difference on both of them, so they're faced 90 degrees. Now this particular Balun, I'm going to start lowering the frequency, going down to 12. 12 is still working very good, and we have very good response from the ferrite cord. We continue down to 20 meters. 20 meters is still working pretty good. Okay, we're going to start seeing a separation in there, but it's still working very, very good. But once we start going down to 40, it's a difference. It's a difference in 40. It's still working, but that doesn't mean that it's working 100%. As we see it there, it's a variable in between a positive and negative in the antenna output. So therefore, that means that the Balun is start having a change based on 40 meters. Okay. Now, if we continue lowering to almost 80 meters, let's see, 80 meters, we see there that positive antenna is completely off from the negative part. Very, very bad. That means that this Guanella Balun is no longer working on 80 meters. Okay. As the signs out there, you have to do a lot of reading if you wanted to do it yourself. There's many companies they make them. I make them myself as well for a response for 80 meters to 160 meters, and then also depending on the type of cord that we're looking for, how many watts, and we have to look different variables in there. But this particular Balun, it's good for literally, let's say 40. I can use it for 40 meters down to 10 meters or 54 megahertz. I think I can go all the way up there. Not as good, but I think for what I'm looking for in this particular one, 10 meters, that's working fantastic. This has been used for lowering the common mode. That's great for that. So we see it in here, facing like 90 degrees. So this Guanella Balun, this design, it's good. This is a 52 core material. Works from 40 meters down to 10 meters. Very, very well. If you guys have any questions, please write it down in the notes. I'll be happy to try to answer them, as I'm still learning on how they work, how the reaction they have. It's just amazing. 73, and I hope this video can help so many that are trying to understand how a ferrite core is working. The ferrite core and the way that it's working at from 28 megahertz down to 7 megahertz. With the analyzer, the SWR shows 1.7. 1.7 will be the highest on 10 meters. 1.3, it works for 40 meters. That means that it's good based on the oscilloscope and how the two parts of the antenna, positive and negative, they're working fantastic between the two of them. There's no variables in there. They're facing at 90 degrees. 73.